explore. And I've already specified this, maybe I'll just reset this. The dependent variable is exam grade. My independent variable, or my factor list, is based off age. So age is what's going to create the groups. The types of plots that I want are, I want normality plots, and maybe histograms. So we've already seen the histograms, but we can always output them again. And that's all we need. So we need normality plots with tests. So I'm looking for Shapiro-Wilkes statistic here, which is a test of normality. So I'm going to hit OK. So I continue, then I'm going to hit OK, and what we'll get is we get a fair bit of output here. You can see what's happening. Okay? The case summary table is here. You can see I've got 996 20 to 30 year olds. I've got 996 30 to 40 year olds, and I've 596 40 to 50 year olds. Okay, so there is a little bit of it. Well, there is a big difference here between them sample sizes here, especially for the third group compared to the other two groups. But let's not worry too much about that at this stage. When we look at the descriptive statistics, and if we were doing an ANOVA, the ANOVA test would actually be trying to ascertain whether the mean values of these groups, okay, the mean values of 20 to 30 year olds, which is 54%, whether that's significantly different to the mean value of the 30 to 40 year olds, which is 67%, or the mean value of the 40 to 50 year olds, which is 63%. Okay? Now, as I said, the Kruskal-Wallis, we're either going to be looking at the mean ranks and seeing whether there's differences in mean ranks, but mainly what you're probably interested in is trying to ascertain whether there's differences in median grades. Okay. Now, once again, to ascertain that there's differences in median grades, the distributions need to be the same. They need to have the same shape, and in this case, I've assured that that's the case by actually generating distributions from a particular probability distribution that's skewed. Okay. So just looking at the normality tests here, okay, you can actually see that in all cases, okay, the null hypothesis for the test of normality, and in particular the Shapiro-Wilkes test, is that the distributions are normal. We reject that position if our p-value is less than their significance level. In this case, well, the p-values are signified in SPSS as sig. So you can see that 0.000 is less than 0.05, so we reject the null hypothesis. So what this is saying is there's evidence to suggest that the 20 to 30 year old group is not normally distributed. Okay? There's evidence to suggest that the 30 to 40 year old group is not normally distributed, and also there's evidence to suggest that the 40 to 50 year old group is not normally distributed. More importantly, that the 40 to 50 year old group's exam grades are not normally distributed. Okay? So you can see we've deviated from normality, and so I should really proceed and do a non-parametric test. Okay? And that's what I'm going to do next, is I want to ascertain whether there's differences across these groups. So I'm going to do a non-parametric Kruskal-Wallis test. So where do I find that? Once again, I go to Analyze. I go down to Non-parametric tests. I'm going to just choose Legacy Dialogues here. And we've got more than 2 independent samples. We've got k independent samples. Actually, we've got 3 independent samples here. So I'm going to choose k independent samples. Let me just reset this. The test variable is our dependent variable. Well, that's exam grade. And the grouping variable is our independent variable, which is age. And we need to define our groups. Well, our groups range from 1 through to 3. That's the way we've labelled them. We've labelled the 20 to 30 year olds as group 1, the 30 to 40 year olds as group 2, and we've labelled the 40 to 50 year olds as group 3. So I'm just specifying the minimum value and the maximum value here with respect to the group ranges. Okay? We hit continue. In relation to options, I'm just going to choose descriptive statistics and quartiles. So this will give us a median value out, albeit it's not the median values that we're looking for. It's not the median values at the group level. This is the median value for all observations pulled together. We're not really interested in it, but I'm just going to just click it so that you actually see what happens here. I hit continue. And by default, I'll just turn that off there. By default, I'm looking for the Kruskal-Wallis H Test result, or H statistic. So I'm just going to hit OK on that. And what I get out is output that looks like this. Okay. What we're interested in is I suppose the results of the test statistic. Okay. The actual Kruskal-Wallis test. The null hypothesis is that there's no difference between either the medians across the groups or the mean ranks across the groups. We reject either one of those particular hypotheses if the significance, the observed significance, in other words, the p-value is less than the significance level that we've set for the test. And in their case, we're just setting it at 0.05. There is corrections you can do for that, like Bonferroni corrections and so on, which compensate for the number of groups that we have. But we're not doing any correction. We're just setting the significance level at 0.05, the 5% significance level. And the asymptotic significance here is less than 0.05, so there's evidence to reject the null hypothesis. But which null hypothesis am I rejecting? Am I rejecting the one that is going to tell me, the one that says that the medians are the same? Am I rejecting that one? Or am I rejecting the one that says that the mean ranks are the same? Okay? So I can only infer that the medians are different, okay? I can only reject that null hypothesis with respect to the median values, yeah, if the distributions have the same shape. Now, you can clearly see from our graphs up here, our histograms, is that the distributions are all positively skewed. They look relatively similar to each other.